To shift it right, pi over 3, I have to know where pi over 3 is first. Pi over 3 is smaller than pi over 2 because the bigger the denominator, the smaller you are. 1 over 2 is bigger than 1 over 100. So pi over 3 has to be somewhere between 0 and pi over 2. I'm not a huge stickler on getting it exact. It is kind of closer to pi over 2 than halfway because pi over 4 would be halfway. So if you kind of picture halfway, it would be pi over 4. Pi over 3 would be about here. So if I needed to graph cosine of x minus pi over 3, we are going right pi over 3. So I'll shift, the very first one goes kind of that far, right? So they'll all go that exact same distance. So I'll move this one here, this one here, this one here, and this one here. And that is the graph of cosine shifted right pi over 3. Okay? Other questions? Cool. Because we got.
How come on this one you shifted by you moved when it was supposed to be when it was 3x over 2, you moved to the left one, and then on those you're just going just to the pi over 3.
You have to look at this number. So that's why I say start with the one that's on your y-axis. Look at your y-axis and then look for the number that's being shifted by. So notice the bell work had it pi over 2, left pi over 2. So I start at 0, 0, and I look at negative pi over 2. That's right here. So I have to shift it that far.
Okay.
Your very first point, this basically tells you where your first point has to go. So if it says plus pi over 2, we have to be at negative pi over 2. That's where my first point goes. Grant asked about negative pi over 3. That would go right pi over 3. So you find pi over 3 in the positive direction, and that point better be above or below it. Okay, so that just tells you how far to left or right. Okay. So you don't get to pick. You're not like it's just one tick mark or two tick marks. It will tell you how far to move it. Okay, and if that doesn't quite make sense, we'll have some examples with more of it in there. Okay. Holden.
For number 17, since it's positive pi in the parentheses, you start on the left, on the negative side?
Well, we should graph regular sine first, right?
Yeah.
Sine starts at 0, 0. That 0, 0 is going to get shifted left pi units.
Okay, because if it's, you're saying, I think you said yesterday, if it's positive, it goes the opposite.
Yeah, it goes left. Yep, so that one should go left. So you are correct in what you're saying. I just wanted to confirm what you were saying. But yeah, our graph would, our fundamental cycle, instead of starting at 0, 0, it's going to start all the way at negative pi. Because this is another example, Will, of it said move left pi. So my first thing I find negative pi, and my point should either be on that or above or below it.
Okay.
Is that a little clearer?
Yes.
Okay. Good. And if you're a little confused, we have more to add to it, so you might catch on as we keep adding stuff, because we go back to the regular stuff. So we covered 2 letters so far. We covered A, amplitude flipping. We covered our C value, left or right, it goes the opposite direction. This is a statement that goes across functions. If it's in the parentheses, typically it's opposite direction. Left or right is always opposite of what it looks like. Today we're going to talk about the B value, and we'll talk about the D value. The B value is that value that's right in front of your X. So if there's a number in front of the X, the period is no longer going to be 2 pi. In fact, if you look right here, it says the period is actually 2 pi over B. We didn't talk about this yesterday, but let's look at our bell work real quick. What number's right in front of X? 1 is in front of there. What's 2 pi divided by 1? 2 pi. That's why up until today, every one of ours had the period of 2 pi, because it was really 2 pi over 1, but I didn't want to get into that because that's a little confusing when we don't know why we said that. So anytime we have a number in front of X, we have to change the period. First of all, so yeah, pretty much. That's why I randomly picked him. He's like, he can answer anything. So our amplitude is 3. He said the period is pi because he looked at that equation. He said, okay, it's 2 pi divided by whatever number's in front of X. And in this case, it's 2. And we'll have 2 divided by 2, which is 1, so it's just 1 pi. The period is now pi. So let's think about this and understand why we're about to do what we're doing. If the period is pi, and I'll come back to this sheet, that slide. If the period is pi, from 0 to pi, it completes 1 full cycle. So if it was sine, it would go up and down and back before it gets to, or right when it gets to pi. Now, if our period is pi over 2, we'd have this little tiny thing. Now, here's the problem. I'm wasting a whole bunch of graph. And I do have to have 4 key points plotted. And I don't want to have to come here and write little small things in here and have it go up or down. So what we're going to do is we're going to zoom into it. So what I want to do is, this one goes out to 2 pi. If the period is pi, I want it to go out to pi and not 2 pi. There's a real easy way to do this, and that's what we're going to do right now. So we're going to talk about how do you label your x-axis. Step 1, find the period. And remember, the period is just 2 pi over b. Once you have the period, you're going to mark the period. And this might seem kind of silly because our period is pi. These are all going to be easy. It gets harder, though. I'm going to show you a real quick way to do this. So mark the pi, and I'm going to put 4 ticks. So you're going to cut out 4 tick marks, and whatever the period is, you're going to put that value there. So let's go back. I'll bring this up again if you're behind. The period is pi, so I count out 1, 2, 3, 4 tick marks, and I put pi right there. So once again, 1, 2, 3, 4, I'm going to put pi right there.
Where'd you get 4 from?
That's just so we can have 5 things marked. So I can have this, so picture it sine. Sine goes here, up, back here, down, and it's done. So I can have a full cycle in there. All right, so 4 tick marks mark the period. Now, it feels like I should mark this one next, but we're actually going to mark the second one next because it's exactly half the size of this. And so it's going to be pi over 2. So we're going to either divide by 2 or multiply by 1/2. I like multiplying by 1/2. It seems like more people are successful doing multiplying by 1/2. But I'm going to put divide by 2. But if you want to put multiply by 1/2, it means the exact same thing. Divide by 2, and then I'm going to put, that's your second tick. So on your second tick mark, so we start at pi, we half it, and half of pi is pi over 2. Bam, I got my next one done. Now half of that would give us that, which would be pi over 4. Once again, pi over 2 divided by 2 can be really confusing to people, but if I tell you pi over 2 times 1/2, we can picture it a little bit better that it's pi over 4. So I like multiplying by 1/2. Once again, on my directions, I say divide by 2, but these are your notes. If you're like, I understand what multiply by 1/2 means, put multiply by 1/2. Divide by 2. That's going to be your first tick mark. So let's look what we did. Period, half, so that's pi over 4. Now we have 4 quarters, basically. This is 1 pi over 4, 2 pi over 4s. This is 3 pi over 4s. So it's half, multiply by 3. Once again, half, multiply by 3. So my last step is to multiply by 3. And I have a little drawing, what I do in my head. So I go multiply by 1/2, multiply by 1/2, then multiply by 3 to get that last one. Now, a lot of you look at me like, oh, it's just 4 points. But you know when you're on a test and time is of the essence, you don't want to spend a whole bunch of time figuring out what 4 things go here. When you can just go half, multiply by 3, and you have all 4 of them labeled. On the test, you have to have all 4 of these labeled. You have to. That is a requirement when you're doing the graphs, that on your x-axis, at least 4 of these need to be labeled. So this is going to be 3 pi over 4.
What's the one farthest to the right?
Farthest to the right is just pi. Pi guy. That comes straight from the period, right? We find our period and we go 4 marks and put it down there. To the right of pi is nothing.
Because 5 pi over.
It would actually be 5 pi over 4. And then we could do 6 pi over 4 and simplify it, 7 pi over 4, 8 pi. I only require you to have the 4. Okay, so now we know we have an amplitude of 3. Is it 3? Yeah, it's 3. So make sure you have your x or y-axis so you can get up to at least 3. So we just have to count up to 3 because instead of going up to 1, we're going to go up to 3. So we'll have 1, 2, 3, -1, -2, -3. Now, sine, we should start figuring out what sine looks like. Does that start at 0, 0, or does it normally start at 0, 1? So either it's at the origin or above. Origin at 0, 0. Sine starts at 0, 0. Sine has both clear mounds. Cosine almost looks like it's just one big mound that goes up. So sine starts at 0, 0. Now, normally it'd go up to 1. What are we going to go up to now that the amplitude is 3? We're going to go up to 3. Back to the sinusoidal axis, down to -3, and back up to pi. The sooner you know this shape, the quicker these problems go, because you really just have to know how it starts and the next point, because everything else reflects, and it makes it really, really easy. So practice, practice, practice. It can be if you break it down. If you get overwhelmed by it, it becomes really hard. It's always easy when I do it. It's just hard when you do it. All right. Let's do the next one. All right, I'm going to ask.
It's good, Jeff.
Okay, my next question is, what is the... So the period is going to be 2 pi over our b value. Our b value is that 3, so it's 2 pi over 3. Here's where that half multiplied by 3 really makes this easier. We take that 2 pi over 3, we count out 4. 1, 2, 3, 4. We write 2 pi over 3. And I'm going to go underneath. Now we're going to multiply by 1/2. And I'm going to write it underneath because it's not always simplified. Because if I multiply by 1/2, we now have 2 pi over 6, which simplifies to pi over 3. Because 2 over 6 equals 1/3, so I'm going to put that as pi over 3. Multiply pi over 3 by 1/2, and you should have pi over 6. Half multiply by 3. So when we multiply by 3 times 3, we're going to have 3 pi over 6, which we can reduce to pi over 2. I don't know about you, but that's a lot easier than trying to figure it out. Especially when you're on a test and you got 5 minutes left and you have 2 graphs to go, you can just go half multiply by 3. Here's the good thing about the period. As soon as you have that done, you're done. It's done. You don't have to worry about it on your graph anymore. Once you have your x-axis labeled, we don't have to worry about the period anymore. That's what's nice about counting out the 4 and just doing it. We don't have to worry about it later on. Okay, then the only thing we have to worry about is our amplitude of being 2. So make sure your y-axis accommodates at least going up to 2 and -2. Sine is the one that looks like 2 full mounds. Cosine is the one that starts high and goes down and comes back up. This is cosine, so we start high. So normally we start at 1, but this time we're going to start at 2. Then we go down to the sinusoidal axis. Then we go 2 below the sinusoidal axis, back to the sinusoidal axis, and back up here. Sinusoidal axis. Hasn't really done much for us yet, but we're going to talk about it when we shift up or down in the next one.
Is it a horizontal asymptote?
It's a horizontal asymptote, but it actually goes through it, yeah. So not really an asymptote.
So it's included.
Yes.
Horizontal asymptote.
But not really an asymptote because it's not hovering around it. All right. So now we did amplitude, we did left and right, we did the period. Now we have to do up and down. That is that last letter.
Let's do it.
The nice thing about up or down is it goes the direction you think it's going to. If it's positive 2, it goes up 2. If it's negative 2, it goes down 2. Here's also the good thing about up or down. It's kind of like left or right. As soon as you get to that stage, you just have to shift all your points either up or down. But I'm going to show you 2 ways to do up or down. I don't care which method you use. Yeah?
Is this the same formula as vertex form?
Well, vertex form is going to be more for like an x squared.
But it's still A, B, C.
Yeah, all functions have the same thing. So I could break every function down to having all 4 of these same letters. But I'm glad you saw that because it looks kind of similar, right? Okay, sine x plus 2. Amplitude, you better have gotten 1. The period is 2 pi. Can someone describe to me why it's 2 pi? Yeah. Yeah, we could either say there's a 1 in front of it or there's nothing in front of the x. They both are kind of the same explanation. There's nothing in front of x or there's a 1 in front of x. So the period is going to be 2 pi. That means I can go down to my x. Oh, I already have it labeled for us.
Oh, yeah.
But if it wasn't labeled for us, we just put 2 pi and do a half multiply by 3. It works with 2 pi as well. Now we're going to shift up 2. The first method is I'm going to just graph everything and shift all the points up 2. My second method, I'm going to use the sinusoidal axis to graph around it. Using the sinusoidal axis means you need to know a little bit more about the function. So let's go ahead and graph this. Sine, I'll put a 1, a 2. That will accommodate it all.
Bless you. Appreciate it, boy.
Bless you, by the way. All right. So we have a sine graph. Sine graph are the mounds on top and bottom, Drew.
How do you know if it shifts like left compared to when it's like up?
Oh, let's do that right now. Let's just stop. This goes up or down. I'm going to change this. Everyone look at how I change it.
Boom.
What direction does it go now? To the left. It goes left 2 because it's in the parentheses. You are taking the sine of all of this. As soon as I do this, we're taking the sine of x, but then we're just straight up adding a 2 after we find that sine of x. It's kind of like if you picture like a square root of x, and then you have a plus 2 versus square root of x plus 2 all underneath. Great question. I meant to show that, but we got that. All right, so guys. Let's get through this Friday. All right, so sine. Sine goes 0, 0. I'm going to use a light color first. Goes at 0, 0, goes up 1, down to 0, 0, down to negative 1, back here. This is just plain Jane sine of x. To shift every point up, you just move every point up. It's not earth-shattering stuff. If you do this stuff step by step, it shouldn't be the most confusing thing in the world. The problem is when you try to do everything at once, that your life becomes very complicated graphing. So if I told you to shift all these points up 2, as freshmen, you would just grab the point and put it up 2. So that first point, instead of being at 0, 0, is going to be at 0, 2. Instead of being pi over 2, 1, it's going to be pi over 2, 3. Pi is going to be at 2. Down here, and there. Here is some extra advice for whenever you shift graphs up or down. We're going to look at the sinusoidal axis. The sinusoidal axis goes right through the middle points. So if I asked you to draw a sinusoidal axis, you should draw a line right here. And here's why I'm going to draw my sinusoidal axis every time I shift it up or down. Amplitude is supposed to be 1. You can easily check, is this 1 above and 1 below the sinusoidal axis? Yes. You guys keep shaking your head yes, but a big majority of you are going to do weird things like this. All of a sudden you'll have this shape. If you draw your sinusoidal axis, it's going to look weird. If you don't, you might not catch that mistake. So draw your sinusoidal axis. So first method, just shift all your points up or down. Easy method. The second method is actually to move the sinusoidal axis first. That way you know you're shifting it correctly. So if we look at the next one, our amplitude you should put down is 2. The period is 2 pi over 1 or 2 pi, but we're going to go down 2.
What do we do if there aren't enough lines, like on the left?
On the left, you're going to make it so it can fit.
So we're going to have to draw.
You're going to have to pick your own values.
Oh, so we can go by like 2, 4.
Yep, you can go by 2, 4, whatever can make it fit. It's where you're going to have to make executive decisions.
That's a lot of. Well, then should we do it for this one? Like.
This one will actually work. Oh, we just have to do one more.
Yeah, that's what I meant.
Yeah. Just add one more if you just have to. If this was down to like -6, we'd have to redraw stuff. All right, let's focus. Because it's important that we know this. We have a quiz on it. It's going to be on the test.
What is the quiz?
The quiz is going to be not next day I see you, but the day after. Thursday or Friday, depending on when we... Okay. All right, let's just go. So we're graphing cosine. I'm going to graph 2 cosine. 2 cosine, instead of being 0, 1, will be at 0, 2. Then it will come down all the way to -2, all the way back up. Remember, I did not shift it up or down yet. You know how good you are at graphing. If you need to graph regular cosine first and then the amplitude, then graph cosine first. Do not be embarrassed by drawing too many graphs. What's more embarrassing is when you get all these wrong on the test because you're too embarrassed to draw more graphs. Okay, so we need to go down 2. So I said we could just shift all our points down 2, but here's a different way. Draw your sinusoidal axis down 2 units. So I'm actually just going to shift my sinusoidal axis down 2. Now I'm going to use my knowledge of cosine and my amplitude to get all of the other points. The amplitude is 2. So we should start at 2 units above our sinusoidal axis. And surprisingly enough, I find this method easier if you know what it looks like. Because cosine now goes to the sinusoidal axis, 2 below, 2 below, sinusoidal axis, and then 2 above. So if you understand amplitude and cosine, and you have your sinusoidal axis, you go to your sinusoidal axis, 2 below, sinusoidal axis, 2 above, and you don't have to worry about moving every individual point. You just understand the flow of it, that it's 2 above, 2 below. Once again, I do not tell you you have to use either method. If you're just like, I don't quite get the sinusoidal axis, then just move your points 2 up or 2 down. Sinusoidal axis is a little bit smoother, a little bit quicker, but ultimately, who cares if you're moving up or down, whichever method you're using. Yeah, Connor.
On the test, do we have to go back and erase?
Nope.
Okay, so we can keep that.
Nope. Here's what you should do on a test. See that black one right there? Let's say it's messed up with a whole bunch of other graphs. All I'm going to do is I'm going to put Mr. Pabian, that's my final graph.
Okay.
Or like shade it in extra heavy and put final graph on there. Okay, now we got 2 big ones. We're going to do one that's not too hard and one that's going to be pretty much the hardest one you'll see. We got 2 to practice. But we might not get to it if we can't, so you guys might just be on your own for an extra one if we can't get to it. We have an order of how we have to do things. I've been doing things in order. I do my amplitude, I do my left, right, and then I do my up, down. I really don't care what order you do things in. However, see this 5th step? That has to be last. The very last thing you're going to do is you're going to shift things up or down. You can do other things kind of out of order, but you can't shift things early. Because if you shift things up or down, and then you flip them, that's not how it's supposed to be flipped.
You do sinusoidal axis first, though, like you decide.
You should do nothing with up, down until you have everything else done. So you should have a graph right before you shift up or down. Does that make sense?
Yeah.
Okay. Even if you're doing it in your head. You can do it with the sinusoidal axis, but people make mistakes, so I just say, do it at the end. You can do it however you want to and see if it works. But for the bulk of you, just do up and down last. Then you don't have to think about it. Okay, so we have cosine x minus pi over 2 plus 2. I highly suggest you point to every number that's not a 1 and tell yourself what it does. That is a safety net for you and a safety net for when I check it. Because you might tell me, hey, Mr. Pabian, negative pi over 4 makes it go right pi over 4. But then I look at your graph and you accidentally shifted it left. I can give you points because you knew it was supposed to. You just made a mistake graphing it. Next time you'd be able to get that right, so I give you points for that. And that plus 2 is going to make it go up 2. That means the amplitude is 1. It does ask for our amplitude. Our phase shift is left or right, so it goes right pi. I already wrote that, so I don't have to write it again. The period I should write down. The period should be 2 pi. And remember, it's actually 2 pi over 1 because there's a 1 in front of the x, but we don't normally write that. So it's 2 pi. I think I already labeled our x-axis. I just have to label my y-axis. Usually in class, I have it work out pretty nice that I can just count by ones. We'll see if that works. Yay. All right, normally I start with just basic cosine. I'll usually throw in the amplitude, but the amplitude is just 1, so my first graph will just be a regular cosine. Remember, sine is the one that has the 2 mounds. Cosine is the one that just kind of goes down and up. It almost looks like one big mound. So cosine starts high and ends high. All right, the next thing I have to do is I need to shift it right pi over 4. So we'll shift every one of these points right pi over 4. Now, pi over 4 isn't written here, but we should realize it's halfway to pi over 2. Will, is that making more sense on how we decide?
Yes.
So pi over 4 is about here. We could mark it, but I'm just saying it's like halfway to pi over 4. So all of these are going to move kind of halfway to that next mark. Now, however you want to do the shift, you can shift all of the points up. We're doing up, right? Up to. Or you can draw your sinusoidal axis up to. I do like to, even if I'm shifting all the points up to, I do like to draw my sinusoidal axis first. Because it lets me know if I'm doing stuff correct. Because now when I shift this up to, it better be 1 above that line. So if I do this right, I should see it's 1 above the line. I should go back to the line. I should be 1 under because our amplitude is 1. I should go back to the line, and I should be 1 over the line. I know most of you won't do this, but I highly suggest you mentally check to make sure everything looks right. Does that look like a cosine graph?
Yeah.
Okay, so that part is right. Does it look like it moved up? Okay, so I at least moved it up. Did it look like it got shifted right? And the amplitude is 1. So we can do a holistic check. Don't check for values as much because you want to hurry up through. Just make sure it does those key things. Whatever you said it should do, you should make sure your final graph at least resembles what it looks like.
Can you keep that up real quick?
I can. Not the negative pi. It's around there.
Oh, the coefficient of x.
But
3x.
here's what I want to point out real quick. We'll point to some things, and we'll figure out what's actually wrong about this. So first of all, there's nothing wrong with saying the amplitude is 2. The amplitude is 2. The 3 is going to affect the period. It would be 2 pi over 3, correct? Here's where we're going to be stuck at. Would you agree that this is going to go right pi over pi units? It's going to go right pi units. It would go right pi units if the period was 2 pi. If I had this graphed all the way out to 2 pi, it would move exactly pi units. However, a lot of you said that the period, that says period. A lot of you said the period is going to be 2 pi over 3, correct? So this right pi is only if I'm zoomed to 2 pi. Our period is at 2 pi over 3. So this new period affects how that shift works. What was that?
Just pi over 3 to the right.
Yeah. Well, it's not. It's still going to go right, but I want to point something out real quick. We need to rewrite this one. When you have a period and a phase shift, it needs to be x minus or plus a number in parentheses. Most of the time, it's already written for you like that. So once again, we need to see how the new period affects the phase shift. And that only works if the b is multiplying to both of these. So if we go back here, we're going to notice that the x minus pi is not in parentheses. So we need to rewrite that using, hang on, let's rewrite right above. So we're going to have sine. We are going to factor out the 3. We need 3 times a quantity plus 1. Guys, don't care if you got it. Don't distract other people. So we have to rewrite this as 2 sine 3 times some quantity. Once again, most of the time this is written for us. But sometimes it's not. We have to catch the fact when the period has not been pulled out, it's got to be 3 times the quantity. So now we're going to have, well, when you factor something out, it's division. When you distribute it in, it's multiplication. So division, 3 divided by 3 is 1. So I have 1x right there. Pi divided by 3 is pi divided by 3. So it'd just be pi over 3. And if you're ever not sure if you did it right, distribute it in and see if you get the same thing out. So if I would distribute that 3, we'd have 3x. 3 times pi over 3 would just be pi. Yep, it's the same thing. But now I can see it's actually going to go right pi over 3. It's actually going to go right pi over 3. Like I said, this is the hardest one for these graphing ones, just because that small little kind of tweak. Yeah, Jagger.
Could you assume that the number in front of the x is just going to go under the base shift?
Yes.
Under the pi?
Yep.
Be the same for the
But here's the thing. Sometimes this might be like pi over 2, so it'd be pi over 2 divided by 3, so you'd have to do that division. But once again, if you don't want to divide by 3, multiply by 1/3. If you don't want to divide by a number, multiply by its reciprocal. So we're going to go right pi over 3. And then we're going to go up. So we said the period is 2 pi over 3. The amplitude is 2. Can amplitude ever be negative 2? No, cool. And then the period, I already did that. What else did I ask for? Phase shift, that's left or right. I already said it said right pi over 3. I don't need to rewrite that. Okay, let's graph this. So I start with the period. Period, 1, 2, 3, 4, 2 pi over 3. 1, 2, 3, 4, 2 pi over 3. 2 pi over 3 times 1/2. The 2's cancel out and you're left with pi over 3. 1/2 times pi over 3 is pi over 6. 3 times pi over 6 is 3 pi over 6, which we can simplify to pi over 2. I am not going to be a jerk. Oh, no. I'm not going to be a jerk. I was going to put both ways down. If you put 3 pi over 6, I'll be okay with that as long as you understand. If I give you, so if you have to go right pi over 2, you understand that would be how far you would go. All right, so we have to graph sine first. I'm going to do sine with the amplitude. The amplitude is 2. Remember, sine starts at 0, 0 and goes up. So instead of going, I should label my y-axis, otherwise I could lose points on the test. You don't have to label every point. I just need to know what you're counting by. So instead of going up to 1, I'm going to go up to 2 because the amplitude is 2. I'll go back to the sinusoidal axis, down here and over here. This is just regular sine of x. Well, I should say with an amplitude of 2. Now, so let's go up last. So that means I'm going to go right first. I'm going to go right pi over 3.
Does that mean we go 2 points?
We're going to go 2 points. Yeah, so we're going to take that first pink, let's go orange. I'm going to shift that over 2 tick marks, basically. And that means all of those points have to be shifted that far. But if you understand what sine looks like, you should be able to understand this first point up to sinusoidal axis, down to back to the sinusoidal axis. Lewis?
Why'd you go right to?
I went right to, because it's negative pi over 3.
Where'd you get the 2 from?
I think he said 2 tick marks. He meant 2 tick marks. He actually meant pi over 3. He was just like, he simplified it by saying, well, I'm just going to go 2 of these marks over because pi over 3 is there. Not to put words in Lewis's mouth, but I think that's what he was. All right, we're almost done. Now what we have to do is shift all of the points up 1. That means the sinusoidal axis will also get shifted up 1. So I'm going to draw that first. I'll give my answer in black. So that orange one is going to go up 1 onto the sinusoidal axis. We should be 2 above the sinusoidal axis. Back to the sinusoidal axis, 2 below the sinusoidal axis, and back to the sinusoidal axis. And we should label that this is our final graph.
If we go past like the original period that we had, do you want us?
I am not worried about it. We're not in an AP class or anything, so I'm good with just that. I don't want to waste your time on a test. Because I feel like you could figure it out, but it's kind of a waste of time to do that. What would the domain of this one be?
3 negative
I think negative infinity to infinity, or I'm just going to put the cap R, or the boldface R. The range is our lowest point. So if I duck down, what's the lowest point I can get to? I can get to -1. If I stand on my tippy toes, what's the tallest I can get to? 3. So it'd be -1 to 3 for the range. In brackets, because those are included in our solution set. So now, looking at this graph, for those of you that I said don't draw further than you need to, does this clarify why I don't want you drawing further? Because you're going to confuse yourself by having it a whole bunch of cycles, and you're like, okay, now I need to shift it, and you're going to have too much stuff on there. So we need to just draw the fundamental cycle. That means 5 points. 5 points are a fundamental cycle. Questions? Yeah.